Our task is to find the extrema, max and min, and to figure out where the function would be increasing and decreasing. To do so, we're going to use the first derivative. But first, I know we could work with this and use the chain rule for the outside and the inside, but we could instead write two factors of that binomial, and we could multiply it out. We'll just call this rewriting the polynomial. When you use FOIL on the first pair, it's x squared minus 3x plus 9 and an x minus 1. We continue simplifying this. That is another version of this function, x squared minus 6x plus 9, and there is an x plus 1. Okay, well, we're still working on rewriting this function. We have more multiplying to do. That's x cubed plus x squared minus 6x squared minus 6x plus 9x plus 9. Cleaned up a little bit, combining like terms. That's negative 5x squared, positive 3x plus 9. Well, this is just another version of the function. And once I have it rewritten like this, I can find that first derivative simply using the power rule. It's 3x squared minus 10x plus 3, and of course the derivative of 9 is 0, but we don't write that. We're looking for critical numbers. So, excuse me, we set this derivative equal to 0, and we solve. Now we can solve that by factoring. We can factor by trial and error, or we could factor by grouping. So 3x squared minus 10x plus 3. I love that trial and error, but here goes grouping. 3 times 3 is 9. We want numbers that multiply to make 9 have the same signs, both negative, and they've got to add to make 10. Your choices are 1 and 9, 3 and 3. We've got the magic pair, and the signs are negative. We could expand the middle, call it grouping, call it the AC method, put the 1x in the front or put the 1x in the back. We group the first two and the last two. The GCF of the first pair is 3x minus 1. The back starts negative, so let's just take out a negative, and the GCF of 9 and 3 is 3. We take out a negative 3, all signs change. Oh, and look, there's a match. These two are the same. Take out the 3x minus 1. We're left with x minus 3. All of this. Now we're looking for critical numbers. Okay, so this was our factorization. In search of those critical numbers, set each factor equal to 0 and solve. We move 1 away with addition. Move this 3 with addition. Undo multiplication with division. At long last, these are our critical numbers, and we use them to break up the number line. We're looking to see, where is this function increasing or decreasing? Are there any extrema? Okay, so we're going to test a value from each region, because if this function is increasing, the derivative will be positive, and if it's decreasing, the derivative will be negative. Let's test anything less than a third, such as 0. Let's test anything between 0 and 3, such as, say, 2. Test anything bigger than 3. How about 4? Now we do plug into that derivative. So that is the derivative when x is 0. And if we do, okay, hold up, what was that derivative? Oh, back when it was 3x squared minus 10x plus 3. So if we plug a 0 in there, we've got nothing, nothing, and we've got 3. What that means is that when we test a value like 0, we end up getting a positive. And since it's positive, we know that the graph is going up there. When we do plug another number in from the middle, plugging it into that function, well, we're going to evaluate, the derivative at 2. If we plug a 2 in, I got 3 times the square of 2 minus 10 times 2 plus 3. Well, that's going to be 12. Take away 20 plus 3, which is negative. Negative 5, if I'm not wrong. Okay, well, the point is that it's negative. So the function is decreasing there. It has a negative slope, or derivative. Let's test another one, like 4. When we do, we plug a 4 into that derivative. So that would be 3 times the square of 4 minus 10 times 4, add 3. Well, that's maybe 48, take away 40, add 3. Okay, well that's 11, but the point is that it's positive, so the function is increasing again. And we know that we're going to have a maximum whenever we go from increasing to decreasing. So there will be a max for this value of x at 1/3. We also know that we've got a min whenever the function goes from decreasing to increasing. So there will be a min here for that 3. Okay. Well, let's go ahead and state our intervals of decreasing and increasing. We'll say that this function is decreasing between 1/3 and 3. We found that it was increasing between negative infinity and 1/3, also from 3 to infinity. Looking for the max and the min, we've got to plug back into the original function, or our rewritten version of the function. Either way. So if we plug into our original version, it looked like this. We said that there was going to be a max at 1/3. So let's evaluate f of 1/3 to find the max. When we do, we've got 1/3, take away 3, square it times 1/3 plus 1. If we simplify this, let's just say we rewrite it again. So we got 1/3 plus 3 squared times 1/3 plus 1. It's okay if we want to use the fraction or the decimal equivalent. That's going to be 1/3 minus 9/3 squared, and 1/3 plus 3/3. That's the square of negative 8/3 times 4/3, which is going to be a positive 64/9 times 4/3. And that will be 256 divided by 27. If we take a look at what is the decimal version of 256 divided by 27, as we did earlier today, that's approximately 9.48. So we were looking for the maximum, and our maximum occurs where 1/3 meets 256/27, or we could say where 0.33 meets 9.48. What about the minimum? We said we were going to have a minimum when x was 3, because we went from decreasing to increasing. Let's evaluate the function, whether it's the original version or our rearranged version, when x is 3. Well, that's 3 take away 3, square it, 3 plus 1, that's 0 squared times 4, which is just 0. So we find that we've got a minimum where 3 meets 0. Okay, we did it all. We found our intervals that were increasing and decreasing. We found a minimum and a maximum of the function.